Hello everyone. Today we're going to look at data sampling and variation in data sampling. But we're going to focus really on just the first two. Qualitative data, which is also called categorical data, is data that are categories. For instance, hair color, there's blonde, there's brunette, there's redhead, there's various colors in between. Blood type, A, B, AB, O, things that are categories. We cannot use math with these. We can't do things like what's the average hair color, what's the average blood type. Those things don't make sense. Quantitative data, however, are data that are numbers, and numbers that are the result of counting or measuring something. So not just numbers, but numbers that result, again, in either counting something or measuring something. So for instance, weight is something that you measure. Number of siblings, something that you count. So if you were just going with what's your favorite number, that would actually be categorical data because it's not measuring something, it's not counting something. So again, it's not just numbers in general, the numbers that are a result of counting or measuring. Within quantitative data, there are two categories. The first is called discrete. So discrete is quantitative data that takes on only certain values, typically found in things that you count. Number of siblings, number of TVs in your house, etc. The other one is called continuous. This is quantitative data that can take on any value in a range, and typically this is associated with things that you measure. Your weight, your height, your distance, etc. It can be any number in a range. It can get as small as whatever the thing you're using to measure it can be. But it can be, a third of something. It can be 0.25. It can be 0.2869452. It can be anything in a certain range. So we're going to do a couple of examples of just figuring out what type of data is qualitative, quantitative discrete, or quantitative continuous. So the first one is a letter grade for a student. So letter grade implies category, which is qualitative. You can have an A, you can have a B minus, you can have a C plus. Those are categories. Versus the number grade for a student. Your number is typically associated with a letter. Again, the letter is qualitative. The number is quantitative. It's measuring your grade. How many points did you get for this? How many points did you get for that? It's counting things. But it's not only counting things, it's also usually the average of something. So it can take on any number, and it is continuous. So you can have a 98.762, you can have a 74.8954333337265545. It can be continuous, anything in that range from 0 to 100. The heights of students. Again, I mentioned it earlier, this is continuous, and again, it's quantitative. Quantitative because we are measuring something, and it's continuous because it can be anything in the range of 0 to realistically 7.5 feet, right? It can be higher than that, but it can be anything in that range. And then D, how many children each student has. So this is counting something, so it is quantitative. And because it's counting, because it's whole numbers, you can't have half of a child. You can't have 0.3 of a child. It is discrete. You can only take on the whole numbers, 0, 1, 2, 3, 4. You can't have things in the middle of them. So now we're going to talk a little bit about sampling. So sampling is determining which sample to study. You don't typically study the entire population because it's usually too many things to consider. It's too much data. So you take a small sample of it. And what you want to do is when you take a sample, you want to make sure that it's representative of the entire population. I don't want to find the US's average IQ by taking people that just graduated from Harvard. Right? I want to take a representative sample of the entire population. One way to do this is to get what's called a simple random sample, typically denoted SRS. This is a sampling method where any group of n individuals is equally likely to be chosen as any other group of n individuals. There are several methods of simple random sampling. There are picking names from a hat. There are random number generators, typically on a calculator or a computer. And there's also a random number table. We're going to do an example of the random number table. I assume people have at some point in their lives picked names from a hat before. So you understand how to do that, right? You take a slip of paper, put someone's name on it, take another slip of paper, put someone else's name on it, do that for however many people you have, put them all into a baseball cap, and then randomly choose how many people you need. So a random number table is something you might not have used before. So what we're going to do is we're going to pretend that we have a population of 20 people, and of that population, we want to choose 3 people. So we have what's called a random number table, and it typically looks like this. It's usually longer, but I'm just showing a piece of it. And we begin by making a list of the 20 people. You can either number them from 0 to 19 or from 1 to 20. Doesn't matter, typically whatever your preference is. And then you look at your table, or rather you don't look at it, and you randomly pick a spot to start. So I'm going to randomly put my finger on a number, and I'm going to start here, 1821. So since we're looking for either, again, maximum 19 or maximum 20, for this, let's do 1 to 20. So I have at most 20 people I'm looking at, so I'm going to look at the first 2 digits of my 4-digit number here. And I'm going to look at my 18. So 18 is in my range from 1 to 20. So whoever was listed as number 18 is chosen in my random group of 3 people. Then I go to my next number, 7963, and I look at the first 2 digits, 79. Say, well, I don't have 79 people, so I cross that off, and I go to my next number, 0379. I look at the first 2 digits, 03. Someone on my list was number 3, so they are now included in my group of 3 people. Then I go to the next number, 8270. Well, there is no one numbered 82, so I cross it off, and I go to my next one, 04. Someone was number 4, so now they are on my list. So whoever was numbers 18, 3, and 4 are my sample size of 3 people. Depending on where you start, and depending on, again, how you numbered your students or your population, you will get different groups of people. If I wanted a 4th person, I'd get number 8. There's no 45, there's no 23, there is a 14, and I'd just keep going like that. If I ran out of numbers and I came back all the way to here, I would start looking at the second set of 2 numbers, and I'd just go down like that. But again, typically a random number table, there are a good 100 numbers on there. So this is a very small size of a number table. So generally they're a lot bigger. But again, you just keep going down the list, and if someone is that number, they get chosen, and then you just keep going down. So that's how you use a random number table. So read through the section. Again, focus basically on the data and then the sampling, and then try the homework problems, and let me know if you have any questions. Good luck.